The important points on this graph that we can use to sketch the antiderivative of this is where the graph has a x-intercept, which we can see is at x equals 3 and x equals 7, and also where the graph is positive or negative. And up until 3 it is negative since it's below the x-axis, and it is positive from 3 to 7 since it is above the x-axis, and negative again after 7. From this we can start to sketch the graph, because since we know it is negative here, it will have a negative slope. And we know from the x-intercepts that that will be a relative maximum or minimum. So since this has a negative slope, it will be a minimum. And since this is a positive part of the derivative graph, the original function graph will be positive, have a positive slope. And again, here's another x-intercept, so that will be a relative maximum since the graph before that is at a positive slope. And this will be a negative slope after that because it is on the other side of the x-intercept, and that part of the graph is negative. The next part of the question asks to find h prime of 3, knowing that h of x equals the integral from 2 to 3x minus 5 of f of x dt. So we can plug in 3x minus 5 into f of t. So f of 3x minus 5. And because of the chain rule, we have to multiply by 3. And this is f, or h prime of 3, so we plug in h, or 3 for x. That is 3 times 3 minus 5, or 9 minus 5, which is 4. So f of 4. And if we look back at the graph, you can see when x equals 4, the graph is equal to 1. So f of 4 equals 1. And if we bring down the chain rule, multiplied by 3, answer is 3.